Now let's take a look at particle rendering, how we can render our particle simulation. So first I'm going to create a very basic particle simulation. So in here I'm going to create a geometry node, and in here I'm going to add a sphere node, and this sphere will going to be act as an emitter. And now let's add a pop network in here. I'm going to just connect into this pop net first input, and let's dive inside. And in here I'm going to just go into this pop source node, and let's increase this number of particles to emit more particles. And now if I were to hit play, and here as you can see we have these particles accumulated. Let me enable my play bar, and in here let's also enable this real-time option so that we have this real-time playback. And to make this particle move, let's add a wind force in here. So I'm going to add my wind node, and let's connect this in here, and I'm going to just add a noise. So onto the amplitude I'm going to just increase its value to all the way up to 1, and now we should see the wind, and here we have it. And right now I think the solid size is too low. It is fine, but I'm going to just increase the solid size. Let's increase the solid size to create these bigger sols. And if I were to hit play, and here you can see we have these bigger sols, these bigger shapes. And after that I'm going to add another wind node. So let's add another wind and connect this in between. And for this one I'm going to just keep the solid size to 1, and let's increase the amplitude, and let's hit play. And we are adding a multiple layer of noises that will create a more interesting looking shapes in our particles. And in here for visualization, let's also add our pop color node, and in here let's add this, and I'm going to connect this in between, and I'm going to use the ramp. And in here I'm going to click on this our vex expression, and I'm going to use the speed ramp, and to use the speed to set our color for the particles. And right now we are using this grayscale ramp. What I can do, I can just click on this knob and I can adjust the color. I'm going to choose a very light yellow color, and for the first knob let's keep it at black for now. And here we have the very nice color visualized. And right now our particles life is too high, so let's go into the pop source node, and I'm going to just lower down this life value. Let's lower this value down to 1. Let's hit rewind, and let's hit play again. And here you can see we have particles and they are dying at the same time. So maybe let's add a variance. So let's change the variance to 1, and now we should have the random life of all of these our particles. And there you go, here we have the random life. And I cannot see the smaller scale noise. So let's go into the pop wind, and for this one I'm going to just increase its amplitude value to something higher value until I see some breakups. And I think now it's just breaking up a lot, so I'm going to just keep this to 1.5, and let's hit play. I think that value is looking fine. And now let's say that we are happy with this our simulation. Let's import this into Solaris for rendering. Let's go back, and in here you can now add a file cache node, because let me add a file cache, and you can connect this and you can write out your particle simulation onto hard drive, because you might be working with millions and millions of particles, and it is a good idea to write out your simulation before rendering. But if I were to middle mouse button, and here as you can see we are not working with a lot of particles, so I'm not going to write out my simulation. I'm going to just create a null at the end for referencing. So let's add this, and I'm going to rename this to out. And in here I'm going to create a LOP net. So let's create a LOP network, and let's dive inside. And in here let's import our particles. So for importing, let's add an SOP import node, and I'm going to pick up the SOP path. Let's click on this and let's select out this out null, and here we have our particles. And now we need to assign the materials, because right now this color has been visualized because we have the CD attribute, but because we are in the lob and we are going to render the particles, we must need to create the material. So in here, let's add a material library node, and I'm going to connect this after that, and let's dive inside. And in here, I'm going to go into the Karma and let's add a Karma material builder, and let's dive inside to have access to the actual material. And here we have the standard surface, and if I were to enable its parameter, here I can define the color of my particles. Let's go back and let's go into the material library and click on this autofill to fill out these slots. And now we just need to assign this. I'm going to just enable this assign to geometry option, and let's drag this in here. And with that, our material has been assigned. And now let's add a Karma render node. Let's add this and let's connect this in here, and let's view this. And onto the Karma render setting, I'm going to use the XPU render engine. So onto the engine, let's change this to XPU. And now to actually render this, let's go into this and click on perspective and change this to Karma XPU. And with that, we are rendering our particles. And here you can see our particles are looking white because our this CD attribute, if I were to change this to Houdini VK, our this CD attribute is not being used inside of our material. I know that the CD attribute is here because I can see the color inside of lobs, but the material itself is not using this CD to set the color. If I were to dive inside and let's go into the material itself, and here you can see this standard surface material is just using its own color. So which means we can just pick any color that we like. I can change this to, let's say, blue. And now if I were to change this to Karma XPU, and here you can see this material is using its color to set the color. To actually import our CD attribute, our this color inside of this material, we can import this by adding a geometry color node. So if you type geometry color, and here we have this node material X geometry color. Let's add this, and this node will import the CD attribute from sops into this Vex builder into this material context, and it is out and a vector. And here you can see if I hover over to this out, and here we have the out, and it is a vector type, which means I can connect this in here. And if I zoom in onto my this material itself, and here we have some collapsible menus, and we know that we want to set our base color, so that is the base, and which means we need to collapse this base. And here we have some other parameter, the first base, and that is referring to its value. And I'm going to just change the color, and here you can see the base color, it is a vector. So let's connect this in here. And now this material is using the CD to set the color, which means if I were to render this, we should see this color applied. And there you go. Here we have the color imported from our sops into this material. And now I can go into the specular, I can play around with the specular value, and right now it has no effect. It has effect, but I cannot see them, and that is because we need to create a lighting in here. So let's go into the LobNet, and in here I'm going to create a dome light to add a simple HDRI light. So let's add a dome light and connect this in between. And in here right now this dome light is using this basic solid white color, but I can define my HDRI in here. So let's pick our HDRI, and I'm going to pick this $sign Houdini pick HDRI. These are the HDRI default. So let's pick this Skylight Garage and hit accept, and here we have the HDRI. And now if I were to change this to Karma XPU, and here you can see we have the shadow information and we have the lighting information. And in here let maybe adjust this background, And to adjust this, let's click on this I button and let's go into the background tab, and in here I'm going to uncheck this display environment light as background. I don't want to see the HDRI in my background. And let's also change the color scheme to dark gray. And there you go. Here we have our viewport visualization. And by the way, it's not the visualization, we are rendering our particles. That is how our render looks like. And here you can see we are also setting our P scale in here. We have some scaling information. And if we, let me change this to Houdini VK and let's go back. And in here, if you middle mouse button, and here you can see we have quite a lot of attribute, but in here we do not have P scale. And if you go through here, you will see that we do not have P scale to set the scaling. So if I go into the LoopNet, and if the input geometry, if your input right now, these particles are also our geometry. So if the input mesh or geometry does not have an P scale attribute, this SOP import node will set the P scale attribute for us. And we can find this if we go into the geometry handling of this SOP node, SOP import node itself. Let's collapse this geometry handling, and here we see this parameter that says set missing width. It says set missing width, but if you hover over to that, here you will see that it says that if the input mesh do not have an a width or P scale attribute, we are going to assign an P scale value by using this parameter. And right now we are using the P scale value of 0.01. Which means if I were to change this to Karma XPU to render our particles, and if I were to increase this value, and here you can see our particle scale has been increased. And same thing, I can just lower this value down, and I am lowering down my particle scale. And I can explicitly say, let's go into the geometry node, I can set my P scale attribute in here. And as you know, we can create this by creating an attribute create node. Let's add an attribute create and let's connect this in between. And in here, I want to create an P scale attribute. So let's type the attribute name, and onto the value, I'm going to give a value of 0.1. And now if we dive inside, and now because we have the P scale attribute, we will be going to be using our 0.1 value, which means now this parameter will have no effect. And here you can see, if I were to adjust these settings, this parameter now has no effect. That is because our P scale attribute has been present, and now this Solaris is using P scale attribute from SOPs to set the scaling. And this set missing width is there if we do not have the P scale attribute. And let's go into the first let me stop the rendering by changing this to Houdini VK Vulkan viewport. Let's go back, and right now we are creating a uniform P scale value. We are creating this 0.1 value to set the scaling for all of our particles. Let's customize that, and I want to set the P scale based on the age of our particles. And we can create this by creating an attribute warp node. So I can go in here and create an attribute warp node, and let me remove this attribute create, and let's connect this. And in here, let's dive inside. And as you know that we have the age. If I middle mouse button, and here you see we have the age information of our particles. Let's use this age to set the scale of our particles. So let's go into the attribute warp, and in here first I'm going to import the age attribute, and we can import this by adding the point node. And in here we need to just type the attribute name that we want to import. I want to import the age, and now I can just export this as an P scale. Let's add an bind export node, and I want to create an P scale attribute. And now I can just connect this in here, which means that we are using the age to set the p scale. So whatever the age is, we will get the p scale value, but that will not create a good looking p scale. Like if I go into my LOPNet, and if I were to render this with Karma XPU, and here you see we have this scaling, we have this quite a lot of particle big scale. And to adjust this, let's go back, and in here, as you know, we are using the pop source, or this life is set to 1, which means that we will have a value of age value in 1, 0 and 1 range. If I go into my PopNet, and let's say you can select any node, you can select null or this TopNet, and you can go into the geometry spreadsheet, and here you can see if you have the TopNet selected, Dynamics has a different type of geometry spreadsheet, which means I just need to select out this SOP node, and now we are in the SOP, and the SOP context has this geometry spreadsheet like this. And in here, if I were to check, and here you can see our age is now set to 1.9, and that is because we also have a variance. So which means some of the particles will get a scale of 1, and some of them will get a age value of 1.9. We know that the age, so let's remap these values. So let's go into the attribute WAP node, and to remap this, let's add a fit range node in here, fit range, and let's connect this. And onto the fit range, I note that the minimum value is 0 and the maximum value is 2, and that is because we have a variance of 1, which means that we will get a max value of age value to 2, and now we are remapping this to 0 and 1 range, which means that when our particles will get born, they will get a scale of 0, and as they get older, their scale will also grow, and we are growing it at the value of 1. And right now the value of 1 is still too high, so maybe let's lower this value down to 0.1. So now we are remapping these values. Let's go back and into the LOPNet, and let's render this again. And here you can see, if I go at the very start value, and here you can see at the very start we do not have a scale. As the particles born and as they age, their scale will bigger and bigger, and I think the value of 0.1 is still too high. So maybe let's go back into the attribute WAP, and in here let's lower this value down to 0.01 maybe, and we can also promote this parameter. So onto the destination min and max, I'm going to just middle mouse button, and let's promote this parameter so that we can just adjust this parameter by onto this attribute WAP node. And from here, let's go into the LOPNet. Let's change this to Karma XPU, and let's see. And I think that scale is much more manageable, and I can reverse the scale. For example, I can say as the particle get older, as they are about to die, their scale should get thin and thin. So let's go back, and in here let's reverse these values. So at the start they will get a value of 0.01 as they born, and as they are about to die, their scale should be reaches to 0, which means that at the start we should see some scale, and as they are about to die, before they are about to die, their scale will get thinner into nothing, and that way we can create this fading effect. And here you can see we at the start we have scale, and as they age, their scale will also get thin. And that's how you can create your p scale to control the scaling of your particles. And let me go back, and in here we are creating the attribute WAP node to create the fit range node, and in here we also have a node called remap attribute. So if I type attribute remap, and here we have it, and this node is actually pre-built to do all of these same thing, and which mean I can just delete this attribute warp, or maybe I can just place this in here, connect this and connect this into there, and I'm going to just place this at this side. Into the attribute remap, we have all of the same functionality built in, and that way we can just remap our values very quickly, but just by using this attribute remap node. And in here we need to define the name, and the original name I'm going to use the age, because I want to remap our p scale by the age. And onto the new name I can create a new attribute, and the new attribute that I want to create is the p scale. So let's type the attribute name, and now we are creating the p scale based on the age. And in here we have the min and max, and we know that our minimum is 0 and max is the true. And now I can just remap them, and in here I can just say the same thing, that at the start we have the scale of 0.01, and as our particles get older their scale should reach to 0. And now we have additional option to play around with the ramp, that is an additional functionality also built in, which means I can just adjust and play around with this ramp value to further refine my p scale. Let's go into the LoopNet and let's render this again. And here you can see we have the same effect, but now we also have some additional functionality. Let me pin this viewport, this rendering. Let's go back, and onto the attribute remap I can just play around with this ramp to further refine my scaling. And that's how you can very quickly remap your values and you can set your p scale. And let me change this to Houdini VK, and to set the color let's dive inside the pop net, and onto the pop color I can just add another knob, and in here you can just customize your own colors like so. And they should, let's go into the Karma XPU, and here you can see our changes has been reflected. I can change some other preset. Let's change this to infrared, and here you can see we have these colors. And that is the basics of how you can render your particles.